Welcome everyone to our webinar titled Challenges and Perspectives on Space Sustainability. Thank you all for your attendance. I'm pleased to introduce Professor Loredana Santo from Vergata University, who has agreed to lead today's presentation about this important topic. My name is Jakub Mirek. I'm an employee at AGH University in Krakow, and I'm also a member of Universech program focusing on diversity, inclusion, and sustainability in space exploration. Today's event is also a part of the Universech program, which is generously funded by Erasmus+. For more information about this program, you can find those informations on our website. You will find the link on chat. And this webinar is recorded and will be available later on the Space Technology Center on the YouTube channel. Also, you can find the link to our channel on chat. Sorry, Loredana, I will mute you because I can hear my voice. Sorry. And if you have any questions, please feel free to ask them in chat throughout the presentation or later after the presentation will be ended. Then you can raise your hand. There is a button in Teams for it, so you can use it later. And before we move to the presentation, let me provide a brief introduction to Professor Loredana Santo. She is a full professor of manufacturing technologies, director of the Department of Industrial Engineering, and of the Space Sustainability Center at University of Rome Tor Vergata. She specializes in innovative process and materials and industrial and space sustainability. Since earning her degree in aeronautic engineering in 1994, she has authored over 180 scientific papers and remains actively involved in various academic and professional committees. So, Loredana, the floor is yours, and we can move to the presentation. Thank you.
Thank you, Jakub, for your introduction. Hello, everyone. I share my presentation. The title is Challenges and Perspectives of Space Sustainability. This is the outline of the presentation, the aim, a brief introduction on sustainability, the space sustainability with a multidisciplinary approach, technical, social, and cultural aspects, research examples for space sustainability, and finally conclusion and future perspectives. The aim of this webinar is a presentation about space sustainability with a focus on potential future life in outer space. After a general description of the topic, examples of experimental research on advanced materials and structures for sustainability will be shown. Finally, challenges and perspectives of space sustainability will be highlighted. As probably you know, a definition of sustainability was given in 1987 by the United Nations Brundtland Commission as meeting the needs of the present without compromising the ability of a future generation to meet their own needs. People, planet, profit are involved, and we have three pillars of sustainable development that promote social and economic well-being while protecting the environment. As you know, moreover, there is the Agenda 2030. This agenda for sustainable development, adopted by all United Nations member states in 2015, provides a shared blueprint for peace and prosperity for people and the planet, now and into the future. At this Earth are the 17 Sustainable Development Goals that you can see in this picture, SDGs, named SDGs, which are an urgent call for action by all countries, developed and developed, in a global partnership. It's possible to extend the concept of sustainability on Earth to space sustainability, but there was no widely agreed definition of the term. I like this definition. Space sustainability is ensuring that all humanity can continue to use outer space for peaceful purposes and socioeconomic benefits now and in the long term. This will require international cooperation, discussion, and agreements designed to ensure that outer space is safe, secure, and peaceful. This is the definition of the United Nations Office for Outer Space Affairs, UNOSA. And I like this definition because it involves people, planet, the environment, all the concepts before mentioned. Taking into account the Sustainable Development Goals, the SDGs of Agenda 2030, it is also space sustainability to make good educational courses in order to spread the concept of sustainable development in and for space, to have the possibility to live on Moon, Mars for future scenario, to find solution for the survival of a human being in space, to make researches in space for better life on Earth, to enhance telecommunication, to maintain the space clean and save energy, to connect visions and cultures for future life in space, to develop space law, space policy and regulation, to promote inclusion, diversity and sustainability in the space field. A lot of questions. And sustainability, therefore, can be examined by different points of view. This is an important concept that I want to share with you. The necessity of study sustainability with a multidisciplinary approach, because the questions are a lot of, and we need to deepen all these questions. You can find in literature many papers about space sustainability, and one of them published in 2023 make this division in sustainability from space, sustainability in space, sustainability for space. First one is by using space as a platform to address global problems, space as service. But there is also sustainability in space, viewing space as a natural resource for preservation, sustainable exploitation and exploration. And there is sustainability for space, depending on the point of view. This one is protecting the terrestrial environment from the impact of space activities. So we can think about the space for the activity in space for Earth, or the activity on Earth for space, depend on the point of view. In this seminar, we want to focus mainly the attention on space sustainability and life in outer space. In outer space, that means on new planets or stratospheric platform and so on. And we need different vision and perspectives to imagine the life in space. And as I previously mentioned, it's very important that the approach is a multidisciplinary approach. So space sustainability can be understood in a broadest sense, from space debris mitigation removal, thinking about a pollution in space, in space manufacturing to study how space is viewed in the different cultures, to the implication that life on new planets can have on human being and social community. A broad vision of space, not limited mission, spacecraft, my field that is the engineeristic field. No, we need to open our mind and to think about other aspects that are relevant and very important for possible future life in space. When you go on another planet, you need the spacecraft for going. But then you need to build houses on the planet and structures for living there. And you need medicine for the humans that live there, and so on. So we need a wide vision of the space and the possibility to live in space. For this reason, we should mainly promote research and education related to life in space and its scientific and technological, economic, legal and social implication. And this is not simple. I think that is possible, but difficult to reach. We can examine some technical aspects important for space sustainability. For example, growth of the space sector, proliferation of space debris, and critical expansion of space traffic. If you think about a commercial mission, now we have a lot of new actors in space. And there is the problem of proliferation of space debris. And there are problems about space traffic. These are problems of pollution of space, but this is one of the aspects related to space sustainability, because we can think space sustainability as a key innovation driver for many business to remain relevant and competitive. Space is strategic for business, and for this reason, space economy in this period is a very important topic to be deepened. And because if we want to remain relevant and competitive, we can invest in this important sector. Another aspect is the expansion of services related to Earth observation and global navigation satellite system. They are very useful for different purposes. If you think space weather, it's so important to have system in space for space weather, and system for monitoring and for observing, for example, catastrophes and wars and other activities on the Earth. And global navigation satellite system that regulate all our communication on Earth and in space. Another aspect, space applications and benefit for humanity. A lot of researches that are carried out in space are relevant and useful for example, in the field of medicine, are relevant for some pathologies on the Earth. And so we can have a lot of benefit from researches in space. Space technologies and application for reducing environmental impacts and promoting social well-being and fostering economic growth on Earth and in outer space. In my field, I'm an engineer, in my field there are a lot of researches about the possibility to reach the space and about material processes, technologies for possible future life in space. And we are working a lot in this field. In this complex, I find it complex scenario, NASA has just announced a new approach to dealing with an increasingly crowded and dangerous environment in Earth orbit with a space sustainability strategy that puts an initial emphasis on analyzing the problem rather than technologies to solve it. This is very interesting, in my opinion, because we are changing the way of manage these complex problems and issues, because it's important to better analyze the problem and then find solution, new technology to solve it. We have a lot of problems to solve in terms of pollution in space. Debris is one of them, and we need technologies to that make possible the solution and reduction of pollution in space. But there is another, there are other aspects very, very important, social and cultural. It's important to spread the culture of space sustainability and to share the benefits of it. We need for reforming a legal framework, as above mentioned. We need that when we go on a planet, we must regulate everything, from the extraction of the resources and the space and so on. It's important that we have that space law can regulate everything in space. We are working for this, and the United Nations are making a lot of progress in this field. Another aspect is sustainable finance for space project. This is interesting because you use money coming from a sustainable project for space project. But there is another aspect, very interesting and curious, the role of religions, because in the world there are different religions, different vision of space, and we need to check the vision of the religions, because in space we need of them, and we need to organize everything taking into account the request of each religion. Another aspect, art in and for space, but not only art, for example, also music in and for space. We need them. For the human, is so important to have art, and we cannot think a space without art. And why not? We need new curricula and projects. And last, the role of future generation. I think that the role of the future generation is strategic for enhancing and improving the space sustainability. They can change the way of thinking with the new system. They can change the way of communication and so on. So I think that we need to involve them in this process of changing for promoting space sustainability. In this frame, I want to give some activities that can contribute, in my opinion, to the space sustainability. The study of a main space colonization in a positive manner, the concept, project and their implication for humans. It's very important to establish the new missions on Moon, on Mars, how they impact on humans. Study of innovative material processes for life in space, for building spacecraft, houses, and systems used in space. Study of space law for regulation in space. Study of sustainable space medicine for living better in space and for living better on the Earth. Studies of astrobiology It's so important, for example, to evaluate the bacteria contamination when you reach a new planet. We must preserve the environment of new planets, so these studies are very, very interesting. Space dynamic studies, the orbit study of the orbits for reaching some, for example, some planets. Studies of technologies and application of communication and satellite navigation, as previously mentioned. Space remote sensing and satellite monitoring studies. Safety and security studies. Space weather studies. Space economy studies. We mentioned it before. New is a human factor and space habitability studies. This is new and important for possible life in space. We need to recreate houses where people can live in a good way. Study for the definition of the paradigms of space sustainability. Study of ethics and cultural traditions for life in outer space. Development of multidisciplinary project proposal to be submitted to various bodies operating in the space field for promoting space sustainability. Promotion of knowledge of the space environment, and we make this in the University project. Thanks to this project, we can spread the concept of space sustainability in Europe, and this is very important for the society. And last, specific training courses for students and professionals in the sector. After this view, my view of space sustainability, I would share with you my research on this topic. Is a research activity for space sustainability. I'm an engineer and I work on innovative materials and processes, mainly for space application. And in space I have tested two different materials, shape memory polymer composites and the cosmic ray shielding materials. I have had the opportunity to know the International Space Station, that is a wonderful place where all countries can make experimentation for knowing well space, and it is a place where testing materials, processing and so on. And I had another opportunity, a suborbital flight. These are new flights, research flight, where we have the possibility to test materials, and in my case materials, for few seconds of microgravity condition, but they are very useful when few minutes are sufficient for evaluating the behavior of your materials or your structures. So my history in space is a long, I define a long history in space. I performed the first experiment in 2011 in a NASA mission in collaboration with the Italian Space Agency and Italian Air Force. And I tested this material that I will describe later. Another mission in a Russian mission on board, the first one on board of the International Space Station, the second one on board of Soyuz 2 module capsule in a Russian mission. Then I performed other 4 missions with many experiments. Mission 9, 10, 12 and 13 is a mission about Material International Space Station experiment in collaboration with NASA Glenn in Ohio. And the last experiment, to experiment in the Virtute 1 mission of Virgin Galactic in collaboration with the National Research Council and Italian Air Force, is a suborbital flight in June 2023. And I have planned a new experiment in the third quarter of 2025 in a space rider mission is a new European spacecraft for space mission. And this is another challenge that I will have soon, and I'm very happy for this opportunity. I have studied shape memory polymer composites because they have interesting properties, very useful for example, for the debris capture. If you look to this image on the right in my slide, you can see the situation of debris around the Earth. We have 1 million of pieces of debris, objects that rotate around the Earth, and it's so urgent to reduce this debris. And shape memory polymer composite can be used for this purpose, and we are working with this target, and I will show you some experiment for making it possible in the future. This material has a particular behavior, because if you have the material in this initial configuration, if you hit the material and apply a force, you can give a new geometry, And if you cool this material, you can store in this new configuration, storing also energy in this new configuration. If you hit again with this material, you can obtain the initial geometry without putting force. This means that you can have a very compact structure on the Earth, and you can open and close this structure in space. The idea is to use this for catch object. And this is a movie in which you can see the behavior. There are some meters that can eat the material, and the material close. On the right, you can see the debris rotate, reach the system of grabbing that is put on a CubeSat, and eat the material, close the debris and catch the debris. This is one of the possible technology that can be used for the debris capture, and for this reason they are sustainable material, not for their chemical nature, but for the use that can have in space. And you can use for this purpose. This is one application of this material, but you can use the same materials in this case, for example, for making these these drug cells. It's possible to use this also for solar system. In this case, is for drug cells that can be opened with the same system that you looked at before, and is useful because you can open the sail on the, for example, on the CubeSat for the deorbiting of the satellite at the end of the life, and promoting the destroyment of the satellite. And this is very interesting. You can see a movie about the opening of this structure. And in this case, we used heaters, but in space they can be activated by solar heating, and this is very, very interesting. These materials and cosmic ray shielding material that I will describe soon were also tested outside of the International Space Station in the Misse flight facility that you can see in this image, in the project Materials in Open Space, in collaboration with Kim de Groot, that is the PI of the experiment about polymers and composite materials in this facility. She works at NASA Glenn Research Center, Cleveland in Ohio. We put different samples in outside of the International Space Station for years and tested the behavior of this material, in particular chain memory polymer composite. In the first mission, MISSE9, you can see the sample of the MISSE9. You can see a window in the sample, because for us was not only a passive experiment in which we want to study the behavior of the material, in particular the degradation of the material in open space, but we wanted to evaluate also the possibility of recover the initial geometry, because this material, as previously mentioned, is a shape memory composite material. And so we put this window in stored configuration, and by solar heating we want that the window close after heating. In the same mission, we put these samples and cosmic ray shielding. This is another important class of material. They are sustainable because we want to shield astronauts and spacecraft in a long flight, for example, from the Earth to the to Mars. We need materials for shielding, and we are studying different combination of materials for this purpose. In this mission, I want to show you some image of the experiment. This is the deck pre-flight, and on orbit you can see some samples on orbit, and you can see, for example, partial degradation of the cosmic ray shielding materials. And in this image you can see after 6 months our sample, chain memory polymer composite material sample. This is the result in flight, and this is before flight and control sample. It's important to know that it's very, very important the position outside the International Space Station and the direction. In this case, the direction is zenith, in front of the sun, so there is solar irradiation, and for this reason material increased its temperature and was possible to close the window, but we obtained it partially closed the window for a strong aging of the material. But this study is very interesting for designing in the future system that can be heated directly by sun and without using of battery or system for heating that are necessary for the material recovery of the geometry. In this slide, we have some conclusion about this seminar. Space research in different fields is always fascinating and challenging. It requires a multidisciplinary approach for possible future life in space. I hope that we can all work together on space sustainability for the well-being of humanity, taking into account all the aspects examined in this seminar, and not only. We have a lot of new aspects that we must deepen in the future. And I'm sure that the project Universe will contribute to this challenging goal. But there are challenges and perspectives that we can face. In the frame of the project Universe, we could propose different tasks to really study space sustainability with a multidisciplinary approach, by starting with a possible scenario of life in space. My idea is to fix a scenario: life on Mars, life on Moon, on a stratospheric platform. How to approach the topic of space sustainability, but with a multidisciplinary approach, not from an engineering point of view. It would be very interesting to have the possibility of making this. Another idea is to organize a space sustainability exhibition for showing activities, ideas, and to spread this concept, not only by seminar, but in a real exhibition. To make a short educational course for kids. I know that in the project we make a course for students, but probably a small course for kids is unique and difficult because the topic is not so simple, but they are the future generation. And if we are able to spread and to give them the idea of space sustainability, it would be very, very important. And why not to write a document about possible topic to deepen in the field of humanities, social science, economy, law, technology for space sustainability. We need to stay together in the same environment and to work together, because together we can share knowledges in different fields, but that can be useful by deepening the topic of space sustainability. I think that it would be strategic for the development of this so challenging topic for the benefit of all humanity. Thank you very much for your attention, and I'm very glad to be here today and give this lecture.
Thank you very much, Loredana, for your presentation. And now we have some time for discussion. So if anyone has a question, please raise your hand or write it on the chat. And Loredana will try to answer it.
I'll try, because the topic is not simple.
Yes, and
Joanna.
it's very complex. And Joanna is raising her hand. And right now I will let you speak through mic. Okay.
Okay, thank you so much, Loredana, for a great introduction to sustainability in space. So my question is very practical, because as you know, we will be trying to give support to teachers from our project to introduce some elements of sustainability in space into their teaching, regardless of what the subject is about space. Is it the materials? Is it the geological course? Is it ICT? So we want to give them some support of where to begin to introduce the subject of sustainability. So my question for you would be this practical question. What would you suggest to the teachers who are designing their courses and they want to include some elements of space sustainability? What would be the first step? Where to look for information? What information to include? What would be your suggestion? Thank you.
Oh, sorry, Loredana, you are muted for a moment.
Okay. I think the best solution is to start by presenting the Agenda 2030, because starting from this agenda and the SDGs, you can focus on the topic of sustainability in general, and then to extend the topic to space, because space is a little bit different from the Earth, but some aspects are common. We want the best for human on the Earth and in space. And starting from the SDGs, we can give the idea of the space sustainability and the idea of the subject on which we must deepen our must be deepened in the courses. But I think that it's better to start from sustainability, the concept of sustainability.
Thank you, Loredana. That makes a lot of sense.
You're welcome.
Thank you, Joanna. Thank you, Loredana, for the answer. And is anyone raising a hand? No, I don't see, but I have a question probably. It is connected with that area of social challenges connected to the sustainability in space and with religion. You said that we have this problem of many, maybe that's a bad word, problem, but we have many religions, and we need to put them in space together, all those people, diverse people. And there is also this issue that some religions are maybe not happy with this space exploration and how we can solve this problem. So if you have any thoughts on that. Sorry, you are muted. Sorry.
The question is not so simple, but I understand that we have different visions and different vision in different religion. But my idea is that we need to deepen the knowledge of the vision in different religion. And why? Because we can, an example, a Muslim pray in a specific direction. And if they want to pray in space, we need to have structures in which you can pray in this direction also in space. It means that we need to understand the needs of different religions and to traduce these needs in structures, in abilities, in space, to permit to follow these religions also in space. So I think that is possible, but we need to study in depth the vision of space in the different religion.
So it's a difficult task, but we need to do this. Okay. But we have a voice on chat from Irina. In my opinion, there should be no religion in the cosmos. Only the law should apply. So not but everybody.
If they want to apply their religion in space, we need to make this for them.
Mm-hmm. Do we have any more comments or questions from the audience? Okay, I can see Jean is raising his hand, so I will turn the mic on, and you should. Mm-hmm. Jean, probably you can speak right now through the mic if you will turn it on. Or if there is a problem, please write the question on chat. Mm-hmm. We can't hear you, Jean, if you are with us. I can speak. You should be able to turn on your mic.
Okay.
Okay.
Do you hear me now?
Yes, we can hear you.
Okay. As far as religion is concerned, it shouldn't be the center of the problem, but I think historically the religions have played a role in planning for future generation. They were, even if you look at the monks in the Middle Ages, they were planning the industrial development and for the future. And whether it has to do with any belief or not, this role is not the role of representing the future generation, is not really taken by other bodies than religious bodies now, and needs to be addressed. That's all my question.
Thank you, Jean. And
I agree with you. I agree. We need the help of actors in active in religion for the future, but this is only one aspect of the social aspect that we must deepen. Not only religion, but also social aspect and so on.
Okay. Thank you for the answer. And Christine is also raising her hand. So I turned on your mic and you should be able to speak.
Yes, can you hear me?
Yes.
So thank you very much, Loredana, for this very interesting presentation. I have a question regarding the process. To me, sustainability on Earth is related to reduce, reuse, recycle. How do you think it could be thought for space applications, space-based moon, for example, space missions and so on? How do you think, except debris removal, how do you think reduce, reuse, recycle could be applied in space? Thank you.
Thank you for this question. For example, in the International Space Station, they apply this because in space you need to reduce, to recycle, and so on. And so circular economy is strategic in space for the preservation of resources in space, because it's more difficult to find water, resources. So in space, you must recycle. And for the debris, the problem of the debris is related to the satellite mission, the end of life of the satellite, and part of the rocket. And in this moment, NASA and other important institutions in space are evaluating different technologies for removing these objects from this orbit, because this is a problem for future mission and for the safety of the planet.
Yes, of course, regarding debris, but do you think debris could be reused, for example?
Are reused? Depends on the debris, because we have different type of debris. Probably some of them can be recycled and reused, but now we are working on technologies for removing them. Mainly for removing, and probably in the future, when we have good technologies for collect them, we can think about reusing them.
Thank you for the question. Probably it could be like with photovoltaics. We have it now everywhere, and we are thinking how we can recycle it. And we know PV also are used in space.
In space, sure.
Okay, so do we have any questions? I don't see on chat and no hands, so probably we can end our meeting.
Thank you.
And thank you, Loredana, for your presentation. Probably this is just a beginning, and we hope to organize more meetings like this, focusing on sustainability, because it's a new topic in our university project. And thank you all for attending. and probably see you soon. And now I'm pleased to invite you to another webinar organized by the Space Technology Center. It is starting at 15 o'clock, and the link is on chat. Probably you will be interested in to take a part in it. It is a more technical topic about spectroscopic ellipsometry for thin films characterization, etc., etc. Presentation will be conducted by Professor Jaglasz. And thank you all for the meeting, and see you. Oh, sorry, Loredana. Yes.
Thank you very much for this opportunity. Bye.
Thank you. Thank you. Bye.